everybody. Here is the worksheet that you may have seen in class. I had this one on the whiteboard and it's now on class notebook for you to access, but these questions have been taken from page 313 of the textbook. These are combination questions, so they're combining all three index laws. The aim is to simplify the algebraic equations, remembering that simplify means to make things smaller. It doesn't mean to solve. You're not trying to find the value of the x's and the k's, the variables. We're simply trying to make these expressions smaller. I'll put that worksheet aside for now and I'll copy over the questions. I don't think I'll do all of them. I'll do some, hopefully ranging in difficulty. So page 313, question 7. Question 7a. X cubed squared multiplied by x to the power of 5 cubed. So straight away, hopefully you can see, like I can, that index law 3 is happening, power to a power, and with our multiplication sign there, we identify it's index law 1 that we have to use as well. Remember in class I say let's do one thing at a time. Let's simplify the two terms in our expression. A power to a power, we multiply them through. X to the power of 6 multiplied by x to the power of 15. 5 times 3. All we have left here is a multiplication, which is index law 1. So we keep the base and we add the indices. Okay, I might skip question B because it's very similar to question A. So let's look at question C, because we have a coefficient here of 2, k4 squared multiplied by 5 k to the power of 5 cubed. So this is similar to question A, as it has index law 3 happening with the power to a power, and index law 1 happening with the multiplication of the powers. However, we have the coefficients sitting in the brackets as well. So what we need to identify is that anything inside the bracket is affected by the power. Anything inside the bracket is affected by the power. So we have 2 to the power of 2. We know that 2 to the power of 2 is 2 times 2. So that is more simply written as 4. We have k to the power of 4 to the power of 2. So we keep the base. This is index law 3 happening here. Multiply through our powers. Okay, let's keep that there for now. Okay, anything inside the bracket is affected by the power. So this is essentially 5 times 5 times 5. It is 5 to the power of 3. Ignore that part for now. 5 to the power of 3 is 5 times 5 times 5. 5 times 5 is 25, times 5 gives me 125. Okay, so we've sorted that out. Now we have index law 3 happening. Keep the base, multiply the indices. Let's now apply index law 1 to finish off. 4 times 125 is 625. Now I've got to go k to the 8 and the 15th. So we keep the base and we add the indices for index law 1 being a multiplication. Question D, question E and question F are all very similar to question C. So I will do question D is like question A. They're quite simple, so I might just do question E. E and F are very similar to C, but we'll have a look at one more like this when there's a coefficient to consider. This is good. It's a little bit different. We have 4 outside the brackets. And then we have x cubed to the power of 2 multiplied by 2 x 4 to the power of 3. Okay, this is good. This is different because the coefficients, these numbers are sitting outside the bracket, which means they're not affected by the power. Only this is affected by the squared, and only this is affected by the cube. So let's just keep 4 here, but simplify this part of our term. We keep the base, we multiply the indices. Okay, again, that 2 is sitting outside the bracket, so it can remain as it is. We keep the base, we multiply the indices. Now we're back to index law 1 again. So we go 4 multiplied by 2 is 8. They've been sorted out. 4 times 2 is 8. Now we have index law 1 looking at us. We have x to the power of 6 and x to the power of 12. So we keep the base and we add the indices. Okay, let's have a look here at question F. Now we'll have a look at one of the divisions. Let's go straight into I. Let's have a look at this one here. I'll bring the camera down a bit closer. Let's have a look at question I together. We have 2p5 to the power of, all to the power of 3 and 2 squared p squared. Okay, let's simplify our numerator. Anything inside the bracket is affected by the power. So 2 to the power of 3 is 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. So 2 to the power of 3 gives us 8. So we've sorted out that 2. Now we've got the index law 3 happening, where we keep the base and multiply the indices. 5 times 3 is 15. Let's have a look now at our denominator. We have 2 squared. 2 squared. 2 squared is 2 times 2, which is 4, and we have p squared left. Okay, so now we have, take away this messy stuff, and we have 8 divided by 4. What is 8 divided by 4? 2. Take away that, we've just worked it out. Now we have index law 2 happening. It's a division. P15 divided by p squared. We know we keep the base and we subtract the indices for index law 2. Okay, and just looking here, we might look at question K. These ones have got a bit more space to do it next to them. So we'll keep working off this paper. We'll do K and then back to J. Okay, we've got, A, 8H20 is as simple as it can get, but that's divided by, okay, let's have a look here. It's index law 3 happening. Simply keep the base, multiply the powers. Okay, the 8's going to come down again because it's not being divided by anything there. Well, it's being divided by 1 really, but 8 divided by 1, if we were to put it in, is 8. Okay, we have H20 and H15 division, which is index law 2. So we keep the base, subtract the powers. Okay, let's have a look at question J. Alright, remember, anything inside the bracket is affected by the power. Right, this one you won't get in your test, something to the power of 10 without a calculator. Okay, you wouldn't get that in your test without a calculator because it is 3 times 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 3. So when the number's that large, you can simplify it by saying it's 3 to the power of 10 still, because the number is too large. On a calculator you could work it out, but without a calculator you wouldn't be expected to work out 3 to the power of 10. It's thousands. But you can simplify this. Okay, you can simplify x squared to the power of 10 because it's x to the power of 20 if you use index law 3. Let's divide that by x to the power of 6 because it's index law 3. Okay, so you're going to just keep your 3 to the power of 10. If you had a calculator you could work it out, but the textbook answer leaves it as that as well, knowing that the number is quite large. Okay, so 3 to the power of 10, but we can simply work that out. Let's ignore it. We've got x to the power of 20 divided by x to the power of 6. It's index law 2. So we keep the base and we subtract those indices. Okay, you can see there's some fill in the blanks here. These ones are quite simple. In your tests, some of the problem solving questions, not a whole page of them, but there will be some questions where you have to work out what the missing power is or the missing coefficient is. For example, these ones are quite simple, but we realise that our end result is x to the power of 15. Okay, we have a look here. Hopefully you can see that this is index law 3 happening. So you have to work out 3 multiplied by something to give you 15. 5. Okay, 3 times 5 gives you 15. Okay, here again, hopefully you realise it's index law 3 happening. Your result is x to the power of 12. You know it's a 4 there. You have to work out what multiplied by 4 gives you 12. Your answer here is 3. Because 3 multiplied by 4 is 12. This is index law 3. I can see a multiplication sign here, so hopefully you can realise that's some index law 2 happening. There is some index law 3 happening here as well. So let's have a look. X squared to the power of 3, that's going to become x to the power of 6 multiplied by, okay, we have to get to 11. Okay, this is index law 2 where you keep the base and you add the indices. So x to the power of 6, which we've worked out from this part of the expression. Okay, we've got x to the power of 6 multiplied by x to the power of something to give us x to the power of 11. So we have to go 6 plus something because index law 2 states to keep the base and add the powers when it's multiplying powers. Obviously our answer here is 5. 6 plus 5 is 11. Okay, which was what the textbook gave us here, x to the 11th. Okay, let's bring this one down a little bit to finish off. We have x, 4, and a box times x, 3 squared. We know it equals x to the 14th power. Okay, let's simplify this. This is x to the power of 6 because it's index law 3 happening. Okay, we know that we have to get to 14. Here we can see index law 2. So this here has to help 6 add up to 14. Right, so 14 take away 6 is 8. So this term has to add to x8 because x8 plus, you know, your 6 is going to get you to keep the base, add the powers to get to 14. So this here has to add to 8. We have 4 something. So obviously 4 multiplied by something has to give us x to the power of 8. So 4 multiplied by 2. 4 multiplied by 2 gives us x to the power of 8. And then we have our index law 2 of keep the base, which is x, add the powers to give us 14. So the missing number was 2, because x4 to the power of 2 gives us x to the power of 8. With x to the power of 6 being multiplied, then we have keep the base, add the indices of x to the power of 14. So our missing number was 2, which gives us x to the power of 8. This became x to the power of 6. Multiplying them through, we keep the base, we add the powers. Please see me in class if you need some help.